Today, we're going to talk about method of undetermined coefficients. This one is the general form and it is the second order non-homogeneous equation with constant coefficients. Yet the right hand side gt can never be zero. And the general solution for the equation is y equals yc plus yp. Here the yc is complementary solutions and yp is particular solutions. In order to find a general solution, we follow three steps. First one is find the yc, second find yp, and the third is add this yc and yp and find the general solutions. We start with the first on how to find the yc. In order to find the yc, we make the value of left hand side equals 0. That is, the value of left hand side will be equals 0, and it is in the form of second order homogeneous equation. We already know after solving this equation we get three cases, and yc will be one of those cases. That's it. And for the second step, that is to find the value of yp, the particular solutions. One way to find it is using method of undetermined coefficient, and it is usually limited to gt being polynomial, exponential, or sine and cosine or its combinations. Let's look at examples. Here, when the value of gt is exponential, the general form of yp is ae to the power kt, where k is just a constant. For the polynomial, there are different general forms of yp that depends on the degree of t. So over here, when uh, is t squared, the general form of yp is at squared plus bt plus c. When it is just t, we get at plus b. But for sine or cosine, we use both sine and cosine on the general form because the derivative of sine involves the derivative of cosine and vice versa. We take one of the functions of yp with respect to corresponding to that of gt, but there are cases where there is overlapping curves where the general form of yp matches with one or many solutions of yc. In such cases, we need to multiply the particular solution, that is yp, with respect to t and get rid of that overlap. So let's look at the example. This one right here is y, the second derivative of y times minus y prime minus 2y equals negative of e to the power t. Here, the first step, that is finding yc, uh, we first of all we solve the solutions. That means they make this as 0 and find the roots, and we get yc as this value right here. And the second one is finding the yp. Here yp, since it is only negative e to the power t, so the general form is this one right here, ae to the power kt. But if we do yp equals ae to the power kt, that is negative t, this one is just as this one right here, which means it overlaps. So in order to get rid of that overlap, we multiply that yp with t. So we get a t e to the power negative t. So just multiply this with t. And after that, we take the first derivative and get the value, and take the derivative again and to get the second derivative and to get the value. So this is y dash and y double dash. Change this, put this value over here in the original equations, and we get, and after solving it, we get a equals 1 over 3. So that means after that, putting the value of a over here, we get yp equals 1 over 3 t. Since we multiplied this with t, we include the t as well. So it's gonna be a t e to the power negative t. Yeah. After that, the final steps, that is add yc and yp. Yc is this value right here, and the yp we just found out, that is this value right here. We get y equals to yc plus yp. So yc is c1 e to the power 2t plus c2 e to the power negative 2t. That is this one right here, plus, and the y yp is this one right here. Yeah.